All operations, rules with zero and absolute value. So a quick review of our integers. When we add, like this first example, we're starting at -7 and we're adding 4 to that, so we'd move 4 to the right. If we add a negative, we move to the left on the number line. If we add a positive, we move to the right on the number line. So here, starting at -7, you're going to go 4 to the right. Now you can think about it and get it that way, but you could also just think of money. -7 means if it's money that you're in debt, that you borrowed money. If you owed a friend $7 and +4, you gave them $4, +4, then you would still owe them $3. So the answer to this first example is -3. The second one, adding, going down. If you have $10, but you owe a friend -21, you owe them $21, and you give them the $10, you're still going to owe them $11. +10 plus -21 is -11. Again, you can also think of a number line. Start at +10 and move 21 to the left. Third example. Now, a lot of students goof up here because they see this two negatives and they think, hey, two negatives make a positive. But that's only true if you multiply and divide. This is adding. And if you have two debts, if you owe two people money, that's not a positive thing. So -16 plus -20 means you owe $16 to one friend and you owe 20 to another friend. So altogether, you owe -36. You owe $36. -36 is the answer. Subtracting 8 minus 11. By the way, this is exactly the same thing as 8 plus -11. You can always take any subtraction problem, make it addition if you add the opposite. These two are the same thing. 8 minus 11, the thing that you should notice there is 8 is smaller than 11. If you have $8 and somebody tries to take away 11 from you, you have a problem. That's why this ends up being negative, -3. -4 minus 4. This is not an addition problem, it's subtraction. If you can also think of a number line. That's a good way to do it here. Start at -4, and when you subtract, you go to the left on the number line. So if you start at -4 and you move 4 to the left, you end up at -8. If you owe $4 and somebody tries to take away 4 from you, then you're going to owe a total of 8. If you take away 4 and take away 4 more, you've taken away 8. This one messes students up the most, probably, because of this double negative going on here. And again, it goes back to what I did right here. You can always take any subtraction problem and turn it into an addition problem if you take the opposite of the second number there. In fact, this is the same thing as -12 plus 9. And this is the case because the two negatives are right beside each other. In effect, they cancel each other out. So this, I like to just change the signs. Double negative becomes a positive. If you owe somebody $12 and you give them 9, you're still going to owe 3. Multiplying and dividing. So be aware that a positive times a positive is, of course, a positive. A positive times a negative, by the way, is the same thing as a negative times a positive, because the order that you multiply in does not matter. If I say 3 times 8 or 8 times 3, it's the same thing. It's 24. That's because multiplication is commutative. You can multiply in any order there and you get the same thing. Now, when you have one negative, your answer ends up being negative. If you have two negatives, this is from multiplying and dividing. If you have two negatives, that ends up being a positive. So these are the rules for multiplying and dividing. If I have a positive divided by a positive, yeah, that's a positive. If I have a positive divided by a negative, that is a negative. If I have a negative divided by a positive, that is a negative. If I have a negative divided by a negative, that is a positive. They are the same. So basically what you got to know, if you have one negative and you're multiplying or dividing, your answer is negative. If you have two, then it's positive. So in this first example, all I do is take 8 times 2, that's 16. I have one negative, my answer is negative. In the second example, I have two negatives. That means my answer is going to end up positive. 6 times 8 is 48, positive 48. Dividing, two negatives make a positive. 8 divided by 4, that's 2, positive 2. Next example, 16 divided by negative 4. If I have one negative, my answer is negative, and 16 divided by 4 is 4. The rules of dividing with 0. To figure this out, let's think of a simple example. When I say 8 divided by 2, that is of course 4. To figure that out on paper, we would have to take 2 into 8. Notice how the bottom goes out front. And that, of course, is how we get 4. Now, notice something. 2 times 4 is 8. Well, if I pick a number and I say 0 divided by 7, and I'm wondering what that would be, I know that, again, I take the bottom, look at my example right here. In fact, let me change colors. So I'm going to take the bottom, which is 2. Here it will be 7. And I take it into the top. All right, again, there's the 8, and there's the 8. I take 7 into 0. And if you guess what this is, and you guess 0, you're correct. Because observe, 7 times 0 is, of course, 0. Just like here, 2 times 4 is 8. 7 times 0 is 0. Where you get into a problem is when 0 is in the bottom of a fraction. So if I give you a number like 11 divided by 0, go back, we don't know what this is, the calculator spits out an error. And go back to the example we did. Let's take, how about this one? 12 divided by 3 is 4. Notice how to divide that out, I take 3 into 12 and I get 4, and how 3 times 4 is 12. Same thing has to happen here. I have to take 0 into 11, and that's my question mark. Well, in order for us to get an answer here, 0 times whatever my answer is would have to be equal 11. Just like here, 3 times 4 would equal 12. And of course, this does not work. 0 does not divide into any number. 0's too small. It goes into any number, an infinite number of times. It's a meaningless thing to say. So what we say is when 0 is in the bottom of a fraction, it is undefined. So be aware that 11 divided by 0 is the same thing as 11 divided by 0. This gives you the answer of undefined. So if 0 is second, if you're dividing by 0, your answer is undefined. If 0 is in the top, your answer is 0. And if you forget this, remember that your calculator can always figure this out for you. When you get an error, that's the undefined. If you get 0, of course, that's your answer. So in this one, the answer is 0. And that is because 67 times 0 gives you the top 0. 0 divided by 85 is 0, because 85 times 0 is again 0. This one is undefined because 0 times whatever my answer would have to be 22. There's no answer to this. Undefined. When we work in WAMAP, they have us write DNE for does not exist, but the mathematical answer is undefined. 65 divided by 0 is again undefined. There is no answer that I could multiply by 0 that would give me 65. Absolute value. Absolute value. For us, we can just think of it as my answer will always be positive. Now, you cannot take the absolute value until you have a single number. So if I was to do this question, -3 minus 11, that is -14, and the absolute value of -14 is 14. I have to have a single number, and then my answer is always positive. If I give you an example that is the absolute value of -7, that's 7. If I give you a question that is the absolute value of 5, that is 5. Notice again, it does not mean opposite. It means always positive. The only way you can end up with a negative answer is if your negative is on the outside. If I ask you for the opposite of the absolute value of 4, the absolute value of 4 is 4. This negative out in front is not affected by the absolute value. This is the opposite of the absolute value of 4. Absolute value of 4 is 4, so this ends up being -4. Whatever's inside, when you have a single number, ends up being positive. But if I have something on the outside, then that's not affected by the absolute value, which is why we get an answer of -4 here. All right, take a look at those 3 examples, and let's go below. Absolute value of -34, always positive, positive 34. The absolute value of 29, always positive, does not mean the opposite. This is 29. And last one, this is the opposite of the absolute value of 99. So the negative's out front. It's not affected by the absolute value. This ends up being -99.